Good morning, everybody. Attention to all final year students. Career evening is happening next week, Tuesday, on the 11th of March. So come through to learn about the do's and don'ts for your CV, networking, and interviews. There will also be a Q&A with alumni from each school. Please use the Career Services portal and the QR code on the posters around campus to book your spot. Thank you. Hi guys, don't forget BC Cares is running a raffle for each virtual chocolates is a valid to the raffle. And please bring all your things to reception from 8 to 12. Thank you.
So it's nice. All right, guys, let's get started. Right. Unfortunately, just as I started the recording, the announcement went off, so that's going to be in the video for you guys to see. Okay, so today we're looking at something called the greatest common factor. Try and go through this as quickly as I can. Firstly, okay, things to remember: prime factor and prime number. You guys know what prime number is, firstly. Yeah, exactly. Right. So prime number is only divisible by 1 in itself. A prime factor is a prime number which is a factor of some other number. Okay. So generally, we'll see in the context why we look at prime factors, but for now, let's look at this thing called greatest common factor with an example. If I take the number 50 and number 30 and break them up into factors, I can obviously break them up further, but we don't. 50 can be written as 10 times 5, 30 can be written as 10 times 3. The greatest common factor between these two numbers is 10. So that's the greatest common factor here. Usually what we would do, I'm just going to write it here, is if I give you two numbers and I say find the greatest common factor, what we do is we break them up into prime factors first, right? So 50, you guys will see the way I do this is I'll just start breaking it up, see what numbers they are divisible by. So 50 can be divided by 2, right? And we get 25. So I'll write this as 25 times 2. That's equivalent. 25 can be broken up further into 5 times 5. So I will write that. 5 times 5, and there's still a 2 here. All right, let's do the same thing with the 30. 30 can be broken up into 15 times 2. All right, 15 can be broken up into 5 times 3. So let's break the 15 up into 5 times 3, and there's still a 2 here. So generally, this is the route we take to find the greatest common factor. We break something up into prime factors. Once we have the prime factors, then we find all the factors that are common between the two. So I'll highlight this in red. All that are common, let's see, we got a 5 on top, we got a 5 at the bottom, that's common. There's another 5 on top, but nothing at the bottom to match, so we'll leave that out. There's a 2 on top and a 2 at the bottom. So these are common between both. So what numbers we end up with are 5 and 2. Those are the two numbers. Multiply them together to get 10. So 10 is the greatest common factor between the two numbers. Okay, you guys all with me here? Okay, perfect. So that's simple stuff. Now let's try it for a bigger number. I'll give you guys a few minutes, maybe a minute to try this one. Find the greatest common factor between 210 and 168. Go up a little. Oh, yeah, I want to see. You want to see the top? Okay. Okay, guys, videos are help. If you want me to come to you, just put your hand up. If you need help, just. All right, guys, let's look at this one together. 210 and 168. We'll start with the 210 on top. 210, if the number is divisible by 2, it's always helpful. So 210 is divisible by 2. We will get 105 times 2. All right, 105, can you break it up further? Yes, we can. We can divide by 5. Right? That's 21. So that's 21 times 5, and there's still a 2 on the side. Right? Sorry, anyone talking to me? No. Okay. All right. So 21 can be broken up into 7 and 3. So we'll do that here. 7 times 3. There's still a 5 and still a 2. I think those are all prime factors now. So we're done there. Nothing further to do. Let's do the 168. Okay, let me try and use my head here a little bit. 168, we can divide that by 2. So let's start with that. That will give us 50, 60, 70, 80, 84, right? 84 times 2. Again, we can divide by 2. Dividing by 2 is always a nice one to do. It's helpful. 42 times 2, and there's still a 2 here. 42 divided by 2 again. That's nice. That can become 21. And there's a 2 here. And there's another 2 2's to remember. Okay, guys in the back, I need silence, please. Today I can't shout over you guys. Okay, so as I was saying, 21 can now become 7 times 3, and there are still 3 2's here. Okay, so now, as we did before, we look for what's common. Change colors for that. So that would be, I'm starting from one side, so 7 is common, right? 3 is common. 5 is not there, we got a 2. 7, 3, and 2. Okay, so 7 times 3 times 2 is our greatest common factor. So it's 21 times 2 is 42, right? Yes. No, that's perfect. Yes. Yeah. It's not showing. Why is it not showing? The red thing, it should be. Oh shit, maybe I'm not sharing the screen. Yeah, that's not good. Okay. Okay, thank you. Is the screen being shared? Yeah. No, I wasn't sharing the screen. Okay, thank you. Okay, so to those on. And the ones you didn't. Yeah. Oh, you mean just the slides of it? Yeah. Okay, right. So guys, those who are watching this later, yeah, we didn't do much luckily without sharing the screen. So I'm just teaching greatest common factors so far. So pause here if you need to read the slides. We just did 2 examples so far. All right, so maybe I don't know, take a screenshot of this and then play the video in my voice if you need it or whatever works. Okay, Sorry about that, guys. Now we're looking for greatest common factor where there are also variables involved. Okay. So this is not too difficult, but let me just give you guys a minute to try this one. Easy. Okay. Do you guys think we should just do this one together? Is it easy? Okay. All right. Let's do that. So I'll write this as 81 C cubed D can be written as 81 can be broken up into what can we break it up into? 9 and 8. 9 times 9. Okay, yeah, let's go that route. 9 times 9 is 81, right? So we find. And then then bring up into 3. Okay. All right. See what you're saying. Thank you. C cubed and D. So then the 9 and 9 can be broken up into 3 times 3 times 3 times 3. The C can be broken up C, 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 and the D is just D. All right, the point here is to show you guys how to deal with variables. All right, and the 45 is going to be a similar story here. 45 C squared D squared. That can be broken up into, let's see, we'll take this as 5 times 9. Thank you. Times C times D. But then 5 times 3 times 3 times C times C times 3 times D. Okay, so now we do the thing again where we find everything common to the top and the bottom. All right, so I'm just going to circle that in red as we have been doing before. All right, so at the top, let's see, I'm going to take 2 3s from the top and 2 from the bottom. 2 C's from the top, 2 C's from the bottom, 1 D from the top, 1 D from the bottom. All right, that's everything that I see. And then what we have here is 3 times 3 times C times C times D, which is just 9C squared D. That's our greatest common factor. Let's make that look nice. Okay, guys, if I'm losing anyone, just stop me, let me know. Oh, it's too easy. Okay. All right, what's happening here? 9C squared. There's the answer here if you guys want to see that. Factor by grouping. Okay. Yes. Yeah, sure. The solution. Yeah. We have they don't cancel because it's not in this equation. Yeah, so if it's equal to that, then we can cancel it, but they're not equal. I think also, yeah. The first 2 lines. First 2 lines. So from here to here, you should. So here, all we're doing is the first step, if you with me here, we just check what's common between both. So now whatever's common, we just multiply them together. So everything that I calculate here, I just multiply together. You can do it with this or with this to get the same. Oh no, kind of the opposite. We're putting a before we circle. Okay, guys, let's move on now to something which I'm going to guess everyone knows how to do. So we're going to do this together as well. And if I lose anyone, just let me know. Right? So factoring out a common factor with something which is a sum or a difference. All right, so here we have. Okay, guys, please close the door if you're leaving. Thank you. Okay, so here we have, maybe you guys can tell me, what do you see that's common between both these terms that I can pull out? 5b. 5b, is that it? 5b squared, right? We can pull out the 5b squared. 5b squared, and then what's left in the first bracket? B 2, right? You guys all good with that?
Yeah.
Okay. I'm annoying people here. He's messing with me. Okay. All right. Okay, you guys can try this one at home. Factoring trinomials. Okay, so this is a thing which, again, most of you guys have probably seen before, and your calculators can do this, right? Most of you. You allowed calculators. But sometimes in the test, they will ask you to use the R and S method to show you're working. So just to be safe, I have to show you guys the R and S method, which you'll see is equivalent to what you've learned before. Right? So also, okay, let's just do one of these. So R and S method just says if you have a trinomial of the form x squared plus bx plus c, the way you factor this is you write it as x plus r, x plus s, where r is a number such that r times s is equal to c and r plus s is equal to b. Essentially, we have to solve these two equations together. So yeah, I mean, this is going to be equivalent to what you guys learned in school. It might just be presented in a slightly different way. So shall we try one with the R and S method just to make sure we know how to do that? Okay. So we're just always going to start with these two equations. We need R times S equal to C. Now in this example here, C is 10. Okay. And we need R plus S to be equal to B, which is 7 in this example. All right. So I find the easiest way to start with this is to just list out the factors of 10, the factors of this number here, and then from there we can select one for which the bottom equation also works. So what I mean by this is factors of 10, I'm going to write them here. We can have 5 and 2, or we can have 10 and 1. I think that's it, right? We can't have any more. So from these two, obviously these two both satisfy this equation up here. Multiplying both of these together will give us 10. So either of these can work. But from these two, which satisfies the bottom equation? 5 and 2. If I add those, I get 7. So this is the one that we look at. And then we simply write our solution as x plus the first number, which is 5, x plus the second number, which is 2. Right? Which is probably equivalent again to what you've done in high school, but just presented slightly differently. Do it again. Okay, let's do it again. All right. It's always good to do these again more than once. So let's take it all out and do it again. On the top, if this eraser will function. All right, so we always start with these two equations. R times S must equal to C, which is 10 in this case. R plus S must be equal to 7 or B. So far, we okay with the setup? Okay, just C and B, right? Okay. Now I always start with the first equation on top. So we just find factors of 10 because those factors could be R and S. So factors of 10 would be 5 and 2 is one example, 10 and 1 is another, because both of these multiply together to give us 10. So both work for the first equation. Okay. Now from these two, we need to find one that works for the second equation. Copies which add together to give us 7. So we're looking for this one here now. Which of these can I add together to give me 7? The first one, right? So that's why we take the first one. So in other words, the first one satisfies both equation 1 and 2. Then we can just write our final answer as x plus 5, x plus 2. That's just standard form. All right. Okay. Yeah, no worries. Okay, so guys, the questions are always helpful because, again, as I said, I know that everyone probably knows how to do this, but learning the R and S method is good because in the exam test, they might ask you to show this method. And then people will wonder what's R, what's S, even though you know how to do this, right? So this will not lose marks for nothing. Okay, maybe we should try another example. If you're taking this down, it's okay. For those who are still ready to work, there's another example at the bottom here. X squared plus 5x plus 6. Try that using the RNS method. Yeah. Did we not do that yet? We didn't do that. That was that planting flower pots thing. Okay. Yeah.
Because I think it's probably just called after it was, I said, it's not looking for that, you know, we didn't do that.
If we didn't do it, it looks like I wrote a solution here, did I?
It did, that's why, but we didn't cover it.
We didn't cover it. Okay. So maybe I should do that. This thing never comes out though, but anyway, I'll do it. Let's. Yeah. Thank you for reminding me. Where are we? Hey guys, if you're busy, keep on working. I'm going to write the solution in the meantime, but don't worry about what I'm doing. You keep on doing your thing there. Yes.
So what if you say x plus 6 and then x minus 1, before?
6 and 1. That wouldn't work because 6 plus 1 doesn't give you 5. If you're not sure, you can always check. You can always write it. Plus 1. And then open it up and check if you get back to the original. Minus sign. What do you mean? Say again?
X plus 1. How do you say x minus 1?
X minus 1. We can try it, but I don't think it will work. Right? So I'm going to try to see if it works. I don't think it will work. If I open it up, I'll end up with x squared minus x plus 6 x minus 6. So this is looking like it won't work already. X squared plus 5 x minus 6. Okay, close, but it doesn't work. Right. Yes. Yes, you are. Yes. You can, but you have to be careful with that because the quadratic formula gives you x is equal to something. So it solves for x. It doesn't factorize. But then if from there you know how to get back to the factorization form, then it's okay. Yeah. Okay, guys, more importantly, let's try this one at the bottom because there's a negative sign there. And this is where people start making mistakes. Guys in the back, please. I need it quieter than that. Thank you. Right, guys, let's try this one at the bottom because this one is where mistakes start happening. Negative 12. Okay, guys, so this one gets a little bit more messy because of the negative sign by the 12. So if I list out all the factors of 12, we're going to have negatives and positives switching around. Right? Would you guys agree all of these are factors of negative 12? I just have a look at it. If I missed any, just let me know. Okay. So all looks fine to you guys? Okay, now we need one of these which add together to give us 1. Can you guys identify that one? Minus 3 and 4, right? So this one here. So that's the one, and that's our solution. Minus 3 and 4. Okay, so it's still easy stuff. Just be aware of the negative sign. It makes things a little bit more lengthy. X minus 3, x plus 4. Okay. Do you guys want more examples?
Yeah, one,
Yes.
just one.
Okay. All right, I think that's it. Okay, let's try this one here. 2x squared plus 10x plus 12. Let's try that one. Now remember, the previous formula we looked at only works if the coefficient of x squared is 1. So we need to factor out anything which makes that different from 1. Right? So since I don't want to send you guys on a wild goose chase here, just write this as 2x squared plus 5x plus 6, and then work with the part in brackets. That 2 is there, but just ignore it. Ignore it, but keep it there. We can't lose it. Yeah. I think we might have done this one before. But anyway, give it a try. Okay, guys, so here again we need r times s equal to 6, r plus s equal to 5. So factors of 6, we'll write them 3, 2, 6, 1. The first one works. I'm pretty sure we've done exactly this example already. But okay, that's all right. So here we have 2 on the outside, so we keep it there. And then we write x plus 3, x plus 2. So just note, if you factor something out at the beginning, you just keep it there. Just don't get rid of it. Okay, and you guys can try these at home as well. Just same idea, factor something out, and then after that you can do your factorization of the trinomial. Okay, I think now we get to something a little bit different. Okay, the solutions are here for you guys to see once you try at home. Yeah. So this is where something weird happens. You guys might have learned how to do things like this in high school. I'm pretty sure it's like a section we touch upon. When the coefficient of the variable squared is not 1. Have you guys done things like this?
Oh.
Some of you guys have? Anybody? Okay, so usually I think, so for me, high school was a long time ago. When I was in high school, we used to do this using some kind of table method to cross-check factors and stuff like that. It's a bit of a messy method. So here they teach us a new method to deal with something like this, which I don't think is done in high school. So let's see, if it's easy, you guys tell me. If not, so we'll try and go slower. So here, the rule is just updated a little bit. We need to find R times S, which is equal to A times C. Right? A is the coefficient of H squared. So in this case, R times S will be 4 times minus 3, which is minus 12. So let me write this at the bottom here. R times S is minus 12. And R plus S, this rule doesn't change. It's still just the middle value, which is minus 11. So this is the first update. Second update, I'll show you guys in a moment. This first part, does it make sense to you guys? Okay. Did I lose anybody here? Lost. Okay. So R times S in this case is just, previously it would have just been minus 3, right? Now it's minus 3 times 4 times the number in front here. That's how we get minus 12. Okay, you guys all got it? Okay. So once we get that, we can now find our R and S values as we did before, but the way we write the solution is different. So let's first check all the factors of minus 12 and which ones work. So we can have minus 12, 1, 12, minus 1. Maybe I should just stop there because that one works. Yes. You can do that, but then again, the quadratic formula will give you H is equal to something. It's as if we're solving for H. But then from there, you can get back to the factored form. It's fine. Yeah. So you have to show me that step, but along the way, when you're solving for X, just leave that part out because this is not solving for X. So here's the quadratic formula. See, the problem is when you do that, you can't show working. That's if they give you marks for working and use the quadratic formula, you won't get the marks for the working. So something like this is a lot of working to be shown. Yeah. Yes, so guys, if you're using quadratic formula, just be aware. If they give you a question like this where you have to show a substantial amount of working, with quadratic formula, you can't get those marks, right? So you can use that to check if you want to. I mean, you can use a calculator to check if you want to. It'll factor anything for you. But anyway, let's make the point that we're making here. How does this differ from what we've been doing already? We got R times S is minus 12, R plus S is minus 11. And on the side, I'm writing the factors of 12, of minus 12, sorry. We know what they are. And we've found one that works already, so I'll stop there. Right? 12 minus 1. No, that doesn't work, actually, sorry. So let's keep going. That one doesn't work. The first one, the one right on top works. Right? Minus 12 plus 1, that one works. So now, guys, I need you to be with me for this. This is new stuff. What we do now is we rewrite the middle term. The middle term is 11 minus 11h. We rewrite the middle term using our factors that we just found. So we rewrite this here as 4h squared minus 12h plus h minus 3. Right, so it's rewritten using the R and S values. minus 12 and 1. All right. You guys all good with that? Now, once we do this, we do something strange. We consider these two and these two to be together. We find a common factor here from these two. So from 4h squared minus 12h, what can I factor out there? 4h. Okay, let's factor out 4h. And then we are left with h minus 3, right? From the second two terms, can I factor anything out? I can't, right? So I'll just leave it as it is, h minus 3. Now I can factor out h minus 3 altogether, right? Because it's common to both of these. So we factor that out, h minus 3, and what's left is 4h plus 1. So that's how you get your answer here. Slightly different than what we did before. Similar idea though. I don't know of another method that we can do methodically like this, because other methods, there's one where you kind of cross-check factors. Yes. I can, go. I'll do that. Let me see if we have another example. Yeah, okay, I'll do this one again. Okay, but do we have any questions now? I'm going to repeat this from top to bottom. Any questions in the meantime? Okay, all right. So, okay, let me just, so I just erase this and do it again from scratch. All right, let's do that. Okay, let's take all of this out. Pretend we don't know anything yet. Okay. Really from scratch here. Okay, so R times S here, you guys are familiar with the old method. The new method says R times S here must be equal to, as before, minus 3 is included. But now we multiply minus 3 by the coefficient of the variable squared. The coefficient here is 4. That's how we get the minus 12. Right. Are you guys okay with that part? The minus 12. R times S must be given by just that number times that number. That's always the case. 8 times C, as the rule says here, 8 times C, and you get 8 times C from the form of the equation on top. Okay. I need you guys to give me some confirmation, or you guys okay? Okay, all right. So then R plus S, this doesn't change from what we did before. This is just the middle value, which is minus 11, right? Or the B value, minus 11. Okay, so finding the two factors is the same as what we did before. We start with the 12 and the minus 12, and we just find factors of minus 12. So I'll list those factors on the side here. Minus 12 times 1, 12 times minus 1, and there's a whole lot, right? There's a lot more. We can find all of them. But we just need to find one of them which satisfies the second equation here, which when added together gives us minus 11. Right? And I think we can see this first one does it. Yep, that one does it. So now what we need to do is rewrite the example using these two values, minus 12 and 1. So we can rewrite it like this. 4h squared. We rewrite the middle term using those two values. So minus 11, we rewrite it as minus 12h plus h minus 3. So we see here the minus 12 and the 1 are both here. Okay, you guys good with that? If you say, yeah, that will be wrong. We need to have the 8 for both of them. Okay. All right, so from there, we just factor something common out from the first two terms and then from the second two terms. So from the first two terms, we can pull out a 4h, and then we're left with something go wrong here. No, it's fine. Is it fine? Yeah, then we're left with an h minus 3. From the second two terms, we can't factor anything, so we just leave that as it is. H minus 3, there's nothing common there. Now h minus 3 is common to both terms. So we pull out h minus 3, and we're left with 4h plus 1. Okay, so that's like factoring on top of factoring. Okay, do you guys need a break at this point? Yes, okay, 15 minutes. Stop the recording.